Now let's talk about the fundamental theorem of algebra. The fundamental theorem of algebra says if f of x is a polynomial of degree n that's greater than 0, then f of x has at least one complex 0. Now, when it says complex, it doesn't mean it's necessarily imaginary. It just means it could be imaginary, it could be real, it could be some combination of imaginary and real, which is how we these all fall under the umbrella of complex numbers. We can use this theorem to argue that if f of x is a polynomial of degree n greater than 0, and a is a non-zero real number, then f of x has exactly n linear factors. So, for example, f of x equals a times x minus c1 times x minus c2 times ... x minus c sub n, where c1, c2 through c sub n are complex numbers. Therefore, f of x has n roots if we allow for multiplicities, meaning if x equals 1 times x, x minus 1 times x minus 1 times x minus 1 can occur. In the last problem, we had x equals negative 1/2 occur twice, so that's a multiplicity of 2. So if we allow for that, you have any polynomial of degree n has n factors. So kind of a cool principle. You might have already thought that happened. I think we've probably talked about it in other videos if you watch my other videos. So let's see about this one. Find the zeros of f of x equals 3x cubed plus 9x squared minus or plus x plus 3. So our p is this constant 3, and our q is the leading coefficient 3. So our p over q's are going to be plus or minus 3. Well, so our factors of p would be plus or minus 1 and plus or minus 3, and same thing for q. So we're looking at plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 1 over 3, and plus or minus 3 over 3, which is just 1. So really we're looking at 1 plus or minus 1 plus or minus 3 and plus or minus 1/3. So this one I'm going to kind of break with tradition. There's rules we learn, and I'm kind of using those rules I already know, that since all the coefficients are positive, one's not going to get you anything. We need some negatives in there to make things start to go away. So I'm going to start with the negative 3. I have 3, 9, 1, and 3. So 3 plus 0 is 3. Negative 3 times 3 is negative 9. And for that we get a 0. Negative 3 times 0 is 0. 1 plus 0 is 1. Negative 3 times 1 is negative 3. And then we get a 0. Look at that. It's a 0. So what's left is 3x squared plus 1. That's a factor. And then x minus negative 3 is a factor. I know we're looking for zeros, so negative 3 is a 0. But we can just take this other part here, this 3x squared plus 1, and set that equal to 0. If it had an x term, I know the x is 0 in this case, the coefficient 0, I should have said. I use a quadratic formula, but I'm just going to solve this. 3x squared equals negative 1, and you're probably seeing the problem that we're going to encounter. We're going to take that square root eventually, and we have x squared equals negative 1/3. And we take the square root of x squared equals plus or minus the square root of negative 1/3. So we have x equals plus or minus the square root of negative 1 is an I over the square root of 3. And if we rationalize that, it's plus or minus I root 3 over 3. And so our zeros are, sorry for the phone call interruption, x equals negative 3 I times the square root of 3 over 3 and negative I times the square root of 3 over 3. So we only have one that was a rational 0. The others are actually imaginary numbers. So there we go.